All right, hi, my name is Paige, and I'm going to tell you a little bit today about how networks can be used in climate research. So the first question is, what is a climate? What's a network? Well, this is a network, but let's start with the basics. A network is made of nodes and links, and the links connect the nodes into graphs like this. And networks are really useful for interpreting and visualizing data. So let's look at some examples. Here we have a node as a person. And one of the links are friendship. We have a social network. This is a very common example nowadays in social media like Facebook and Twitter, but it also gives interesting information about how we all interact. So we can take a look at the second example. In this case, the nodes are published articles, and the links between them mean that they are cited by the same paper. This is called a co-citation network. As we can see here, we can look at a real example in the realm of philosophy, and if we take a closer look, we can see that there's an actual structure to the network. We see different clusters of points, for instance. And these clusters, in this case, given the data, probably mean that these papers are talking about a similar topic. We also see that there are some nodes that have a lot of links into them. Well, it means that they were cited a lot by definition, so they're probably pioneering articles in their field. We can take a look at a third example, power grid networks. These are very important in society nowadays, where we get power from the source to the users. We can take a look at Northern Europe, sorry for the bad quality, but we see two new things here that we didn't see in the previous examples. One is spatial embedding of the network. So in this case, the physical location of the nodes matters, because there's physical locations in space. We also care a lot about stability of these networks. If we had one power source fail, we don't want the whole network to collapse. So this is a lot about networks, but we should move on to climate networks. So what are the nodes in a climate network? Well, the nodes are the data points. And what is the data? Well, the data can really be anything that you have. It could be rainfall data, temperature, pressure, wind fields, salinity, pH, hydrologists, anything that just has a time series. So if we take an example, we take rainfall, for instance. So here we have 3 points, and they each have a time series for rainfall in a given location for a given time period. We take, for every pair of nodes, we compare the two time series and see how similar they are. The pairs of nodes with the highest similarity between the time series get a link between them, and that's how we create the climate network. So once the climate network is created, we compare it to observations. So let's say we look at this node here. It's a hub of the network. It has a high degree, lots of links coming out of it, like we saw in the co-citation network. In this case, it probably means that it's very important for the flow of rainfall in the system. We can also look at the stability of the network. What if we were to remove a couple nodes, like the ones indicated here? It would change the structure of the network drastically. Instead of having this fully connected network, we'd suddenly have two clusters on the left and the right with no information flow between them. On the other hand, if we remove for the white X's, not much of a change in the structure. This means that the white node has a very low betweenness, and the two red X's have a high betweenness. And they're important for the flow of information in the network, or rainfall. This is an example from one of my research projects. It's from the Indian summer monsoon in the Indian Peninsula. It's pretty cool. So let's sum it up. Well, why should we use climate networks? Well, it's really nice. We don't have to make assumptions about the system. This is great for complex systems like the climate, because we don't actually know everything that's going on. We can just take the data and see what kind of structures and patterns we see. They're also very versatile. You can use them in many different types of data, as I said, and you can use them in different temporal and spatial scales. You can also tweak them to your own desire. You can use directed networks if you'd like, where the links point from one side to another. You can have weighted nodes, where certain nodes count more than others. You could also use interacting networks. Well, this could be great for climate because you have many interacting components, like the ocean and the atmosphere, and you can have them interacting with each other. There's also evolving networks, which could be great for climate change. You can see how the networks evolve in time and see if you can see any patterns. So that's the talk. I hope you enjoyed it, and I hope you learned a little bit about why climate networks can be useful in climate research. Thank you.